Okay, everyone. So in today's class, we will study about force equations. Okay, how to write force equations and how to solve, how to find the values of acceleration, and then we'll continue our constraint motion. Okay, everyone. Okay, right? Some noise is coming. Is it fine now? Okay, okay. Okay, everyone. Yeah. Can you see the screen, everyone? Can you see the black screen? Yes. Okay. Okay, everyone. So in last class we studied motion in 2D, right? I'm using directly phone. I'm not using mic. Okay, I'm just using phone. Is it fine? Wait, let me hear. Okay. Okay. Actually, the phone is quite near. That's why. Wait. Is it fine now? Right? The phone is quite near to me. That's why. Okay. Okay, everyone. So, what we studied in last class? Tell me what we studied in last class. Tell me. Anyone? Equations of motions and relative motion, right? We have studied relative motions. Okay, very good, very good. So today we will study next topic. Okay, right? So I guess all of you are studying this chapter called force. Right? All of you are studying this chapter called force. Okay, right? Is this chapter have been finished? Tell me, is this chapter have been finished? Yes or no? Finished, right? Okay, very good, everyone. So we will start this chapter, okay, and we will extend this chapter, right? We have studied vectors, so we will use vectors in this chapter, okay? So when we talk about force, this is a chapter that we have studied in class 8th also, right? And then we are studying in class 9th also. So this force, right? When you talk about force, you think about push and pull, right? Okay. Then in this class, right, in class 9th, you think about Newton's law, right? Got it? Right? You think about Newton's law, right? What is Newton's first law of motion? Tell me. Newton's first law of motion. Anyone? Yes. So first law of motion is law of inertia. Law of inertia, right? What does this say? Tell me. What this law says. Tell me, everyone. Law of inertia. Okay. So what does this say? Yes, very good. So it says that an object in motion, an object in motion will remain in motion will remain in motion and an object in rest will remain in rest. Remain in rest unless and until external force is applied. Unless and until an external force is applied. Is applied. Right, everyone? Tell me. Right? This is your law of inertia. Or I can say that object have tendency to retain its configuration, right? Retain its state of motion. If it's motion, it will be in motion, and if it's in rest, it will be in rest unless and until an external force is applied. Right, everyone? Tell me. Right? Yes? Oh, okay. Very good. Right? So this is your law of inertia. What was second law? Tell me. What was second law? Second law. Yes, right? So second law states that net sum of all the forces, net sum of all the forces, all the forces acting on an object, okay, acting on an object, okay, is equal to its rate of change of momentum. Its rate of change of momentum. Of momentum. This is your actual expression for second law of Newton's second law actually. Okay. Yes, very good. Very good. So I can say that summation. Summation means sum of all the forces, right? F. Summation of all the forces is equal to d mv by dt. Got it, everyone? Right? Because rate of change of momentum is differentiation momentum with respect to time. Yes or no? Tell me. Yes or no? Right? This is your actual expression. Now we know that mass is generally constant. So if anything is constant, we can take it outside. So it will be m dv by dt. Now what is dv by dt? Tell me. What is dv by dt? Summation. Where this is called as summation. Means sum of all the forces. It is just a sign of sum of all quantities. Okay, right? Sigma is called as summation. Okay, this is sigma and it's a sign of summation. Okay, now dv by dt is actually a, so it is ma. Okay, right, everyone? That's what many of you were saying. F is equal to ma, right, everyone? So this is your Newton's second law, right? Now, what is Newton's third law? Newton's third law is fairly easy, right? Newton's third law is very easy. Yes, very good. Every action has equal and opposite reaction. Very good, right? Every action have equal and opposite reaction. So we will discuss the second law in detail today. Okay, we will discuss the second law in detail today. But before that, let's have very easy problem to revisit our concept of vectors and differentiation. But Vastav, right? Rate of change is differentiation only now. See this? That's the basic definition, that net sum of all the forces is equal to rate of change of momentum, right? And this rate of change is actually differentiation of momentum, which is mv. Momentum is mass into velocity. Okay, that you have studied, right? Momentum is equal to mass into velocity. Okay, now rate of change of momentum is dmv by dt. Now since mass is constant, we can take it outside. Okay, so we are left with dv by dt. Okay, everyone. So I guess everyone is clear about that. Now before starting, let's have a very basic problem. Okay, very basic problem. Now if force acting on an object is 2i cap plus 3j cap minus 5k cap, okay, on a body of mass 2 kg, find its acceleration. Find acceleration. Tell me. Very basic problem. Everyone should be able to say. Yes, very good. Very good, Prahlad. Janvi, you made a mistake, right? See, what is the force equation? What is the formula here? Okay, just think about this. We have F is equal to mass into acceleration. Yes or no? So I can say that acceleration is equal to force divided by mass, right? Okay, sorry, my laptop again gone hang. Wait, I'll just. So all of you got this? It would be divided by 2, not multiplied by 2. Okay. Because I'm asking you to find acceleration, which is force by mass, not force into mass. Okay, so I guess everyone is clear. So the answer is this now, right? Answer just divide this by 2. So it will be I cap plus 3 by 2 j cap minus 5 by 2 k cap. As simple as that. Just divide everything by 2. Okay? Okay, everyone. Now let's see second problem. I'm not teaching any new concept for now. Okay, I'm just using vectors for whatever you have studied already. Okay? Problem 2. Now, suppose I'm having an object. Just imagine I'm having this object. Okay? And the mass of this object is 5 kg. The mass of this object is 5 kg. Now we have a force in this direction of 10 Newton. We have force in this direction of 20 Newton. We have force in this direction of 10 Newton again. And this angle is your 45 degree, right? Okay, find acceleration. Find acceleration. Okay, okay, everyone. Try solving this now. Take your time, it's fine. Try solving this one. Okay, which concept we will use here? Tell me, which concept we will use here? Anyone? Vishya is here. Vaishnavi, Navya, Janvi, Avya. Okay, yes, addition of factors. But yes, Prahlad, very good. resolution of vectors first, right? Yes, Vasta, resolution of vectors. So we will resolve our vectors in x component and y component, right? Okay, do that everyone, do that. Everyone try that. Okay, let's solve this. So I can say that first, how many forces do we have here? Right? Think about the forces. We have three forces. F1, F1. Let's change the color. Now this is F1, this is F2, F2, and this is your F3. Okay. Now F1 is already along axis. So F1, or you can have another figure like this. Okay. Now here, this is your F1. This red one is F1. This is your F2, and this is your F3. As simple as that. F3, F1, F2. Okay, right everyone? Right? So F1 is 10 I cap. F1 is 10 I cap. F2 is equal to minus 20 J cap. Newton, anyways. Now F3. Now F3 you have to resolve. Since it is 45 degree, and in first quadrant, you can write it as 10 cos 45 degree I cap plus 10 sin 45 degree J cap. Right everyone? Yes or no? And we know that summation of F is equal to ma, mass into acceleration. Now summation of F means sum of all the forces. So just add them. 10 x component. So 10 plus 10 cos 45. Cos 45. This is your I cap. Okay, plus J component 10 sin 45 degree minus 20 J cap is equal to mass into acceleration. Yes or no? Tell me yes or no. Right everyone? Everyone is getting this? Everyone is getting this? Okay. Now 10 plus 10, 10 cos 45. 10 common, 1 plus 1 by root 2 I cap plus take 10 common from here. So it will be 1 by root 2 minus 2 J cap is equal to 5 into acceleration. Now acceleration is equal to this whole divided by 2. Now where K component is not there now, right? Force is only in X and Y axis, right? It's not in Z axis now. So A will be, just divide everything by 2, no, sorry 5. So 2 bracket 1 plus 1 by root 2 I cap plus 2 1 by root 2 minus 2 J cap. You can simplify this also, but again that is just your normal calculation, right? I hope all of you understood the method. Tell me yes or no. All of you understood the method, right? This is called as superposition of forces. Okay, right? This is called as superposition of forces. Means summation of all the forces at one point. Okay, so shall we solve one more problem? Tell me, shall we solve one more problem? Yes, it is a resolution vectors only now. Okay, okay, so let's solve one more problem. Okay, So number 3. Okay. Now again, right? Suppose I'm having this box. Mass is 2 kg, and the forces are, this is your F1 in this force, this is F2, F1, F2, F3, and this is F4. The angle, this angle is 30 degree, and this angle is 60 degree, right? Magnitude of F1, 10, is equal to F2, is equal to F3, is equal to F4, right? So the magnitude is same. Okay, magnitude is same. Sigma is just the sign, right? For example, this sign you use for triangle, right? Triangle ABC. Yes or no? This is used for angle ABC, right? In the same way, this is used for summation, sum of or addition of all the quantities. Okay, so if you are writing summation of F, it means sum of all the forces. I don't know, Navya. I guess I'm hearing myself. It's fine. I can't hear any noise, I guess. Okay, so try to find acceleration. Okay, try to find acceleration. Okay, try to find acceleration in this case now. I'll give you 2 minutes. Wait. Yeah, I'll give you 2 minutes, everyone. Okay, everyone. I guess it's enough time. Most of you have already attempted. Okay, very good, everyone. So just look at the screen. Okay, I'll solve. So let's see. So F1. Okay, first I'll just make a better figure. Okay. Now F1 is, tell me, this one, right? If this angle is 30, then this angle is also 30, right, everyone? Okay, this is your F1. Now F2 is this one. This is F2 along the axis. Okay, okay, Ashila, we'll check, right? Just check your answers, everyone. Check your answers. F3 is in this direction, upward direction. F3 and F4 is in this direction, but this angle is 60 degree. F4. Okay, so let's break it down. Okay, break it down. F1 is equal to what? F1 is 10 cos 30 degree I cap plus 10 sin 30 degree j cap. Okay, F2 is 10 I cap. F3 is equal to 10 j cap. F4 is equal to 10 cos 60 degree I cap minus 10 sin 60 degree j cap. Yes or no? Tell me. This is all the forces. This is all the forces. See, right? See the arrow. Arrow is in this direction, right? We can shift it parallelly, right? Now, if arrow is in this direction, then it is actually your first quadrant. Okay. See, arrow is in this direction. It is not in this direction. There's a difference, right? If a vector is in this direction, it is your first quadrant. But if a vector in this direction, it is your third quadrant, right? Okay. So I guess someone had made that mistake, but you should be able to identify the vector is in which quadrant. Okay? Okay. So all of you got this, right? Now just add them. Just add them and divide by 2. Okay? Right, everyone? So let's see. So F net, summation of F is equal to summation of F is equal to m into acceleration. Okay? So acceleration is equal to net sum of all the forces. So 10 cos 30 degree plus 10 cos 60 degree I cap plus 10 sin 30 degree plus 10 minus 10 sin 60 degree j cap divided by, or I'll just write it over here for now, 2 into a vector. So this is equal to what? Take 10 common, cos 30 root 3 by 2 plus 1 cos 60 1 by 2 I cap plus 10 common sin 30 1 by 2 plus 1 minus root 3 by 2 j cap. Okay, right everyone? So your answer should be 5. Acceleration should be 5 by 2 root 3 plus 3. Okay, I cap plus 5 by 2 3 minus root 3 j cap. Got it everyone? Tell me, everyone got this? Okay, very good. Anyone have any doubt? Tell me, anyone have any doubt? Or you understood the concept? No, I've taken, see, I've taken 1 by 2 now, right? If you take LCM and take 1 by 2 common, right? It will be this now, right? Divide everything by 2, it will be 5. Then take LCM, right? After taking LCM, 1 by 2 would be outside now. Okay, that's what I did. Now there, what is the LCM of root 3 by 2 plus 1 by 2? It would be root 3 plus 3 by 2. So this 2, 1 by 2, I have taken it outside, as simple as that. Got it? Got it, Navya? Ishira, what doubt you have?
Sir, I have a doubt regarding the question interpretation, sir. Actually, when we consider F1 force, here the angle is made by head of the vector F1, sir.
Yeah.
But angle should be made when two tails get joined. But here head is making the angle, and
No,
how can
see,
we consider
this
30 degree as angle?
this is not a vector now, right? Just think about this. This is your, I've just showed this one to take a reference of x-axis, but this is not a vector, right? Okay, and see, if this is given as 30 degree, what does that mean? It means that this is actually this vector, right? So this angle is your actual angle. So it is your vertically opposite angle now. So this is also your 30 degree, right? Got it? Yashila, got it?
Yes, sir.
Okay. So next problem. So I hope all of you understood resolution of vectors. Okay? Yes, I hope all of you can solve problems on resolution vector. So let's start next topic, okay, which is called as free body diagram. Free body diagrams. Okay, okay. Now, yeah, F4 is already F4 is already in third quadrant, sorry, fourth quadrant now, right? See, tails of all the forces should be at the origin. Okay, that's the concept. Tail of all the forces should be at origin. Okay, that's why you will move only those forces whose tail is not at the origin. For example, F1. For F1, it was F1's head was in origin. If you take this example, okay, right. So force body diagram. What is force body diagram? So if you have to understand what is your force body diagram, right? This is nothing but representation of of all forces, all forces on any object, on any object. Okay. So what I was drawing here, right? What I was drawing over here, it is your force body diagram. Okay. Force. This one, it is called as free body diagram. Okay. Free body diagram in here. So see, if you talk about this diagram, right? So what is this diagram? This diagram is called as free body diagram, where all the forces are acting on this object, and we will show the direction of all the forces. Okay. Now, in most of the problems, you have to identify that what are the forces acting on an object. Okay. So let's see the cases, right? Okay. Let's see the cases. So just take case one. Case 1. Now, we have an object which is tied to a thread and hanging from a wall, right? Now tell me, what are the forces, right? Suppose this is your object. So what are the forces acting on this object? Tell me, right? Gravitational, very good. What is the direction? What would be the direction of gravitational force? Downward. So this. And what would be the formula? What would be the magnitude? Tell me, gravitational force is equal to how much? mg, right? If mass is m, it is mg. Yes, very good. Is there any other force? Tell me, is there any other force acting on this object? No, we don't consider air friction. We don't consider air friction or drag, anything like that. Okay? Yes, Sheila, very good. Now just think about this, right? Is this object going down? Think about this. Is this object going down? Yes or no? No, right? Now we have studied that if an object is not moving, then there should be balanced force, right? I hope you remember the concept of balanced and unbalanced force, right? Okay, so if the object is not going down, there should be a balanced force. There should be a force which will balance this mg, right? Okay, and what is that force? So there should be a force, I can say that, there should be a force which will balance this mg, right? So if mg is downward direction, there should be some force in upward direction, right? Yes, so I can say that this string, right, or this thread will have some force, and this force is called as tension force. Force due to strain. Force due to strain. Due to strain. Okay, is called as tension. Is called as tension force. Okay, got it, everyone? Tell me, got it? Okay. So this is your free body diagram. If an object is hanging, okay, right everyone? Tell me. What you did get? I just said that if an object is hanging through a thread, right? If it is tied to a thread and hanging from the wall, I can say that on that object there will be one force in downward direction, which is mg. But since object is not falling down, there should be a force in upward direction which is balancing that mg, right? Okay, what is that force? Now that force is due to strain, okay, and it is called as tension force. Okay, got it? Tell me, got it? So the free body diagram of this object is this: one force in down direction mg, one force in upward direction tension. Now since it is not moving, what would be the acceleration? Tell me. Since it is not moving, what would be the acceleration? 0. So can I write like this? This force equation will be mg minus t is equal to 0. Right? This is your force equation. Any force due to string, right? Due to string, and it doesn't mean that it is in upward direction. It will be in the direction of string. Okay, it will be in direction of string. Okay, right? So this is your case 1. Now let's see. I'll just extend this concept. Now let's see who have explained. Sorry, who has understood? Who have understood the concept? It is equation now. Force equation, right? There's only two forces in y-axis, right? We just equated it. Net sum of all the forces in y-axis is equal to mass into acceleration in y-axis, which is 0. So mg is down direction, right? So mg minus j cap and t j cap. So if you add them, either you will get t minus mg is equal to 0 or mg minus t is equal to 0. Okay, right everyone? Okay, now consider this case. Consider this case. Okay, this is a mass which is tied by two strings. Okay, this is your 40 degree. Okay, just make it as 60 degree. Yes, yes, I'm writing on the screen. Now see, for same string, tension is same. Is same. For different strings, tension is different. Okay, as simple as that. It's a theory. Makes sense now, right? Okay, very good. So this is, suppose this is T1, then this would be T2. Now, draw free body diagram. Question is, draw free body diagram and write the force equation. Okay? Same string means only one string, right? Same string means same string. That's the basic English. I don't know how to explain same string means. Same string means that string only, right? We will discuss the pulley and all, then you will understand. Okay. Okay. So first, not delta T na Prahlad, you have to use, right, the concept that we have studied today, all the concepts. First of all, right, draw the free body diagram. Everyone, try to draw the free body diagram, right? So this is your object This is your object, right? Now, what are the forces acting on this? Downward direction, mg. Okay. Upward direction, we have T1, T1. And in this direction, we have T2. Okay. Now, this angle is 60 degree. So this angle is your 30 degree, right? Okay. This is your 30 degree. Yes or no? Right? Using your concept of which diagram? This one or this one? This is the actual diagram. This is your free body diagram. This B is your free body diagram. Okay. Now this is 60 degree, right? Just think about this. If this is 60 degree, then this angle will be what? This is your 30 degree now, right? This is 60 degree, then this should be 30 degree. Got it? Right? Okay. Now, try to write the free body diagram. Prahlad, in a right angle triangle, if one angle is 60 degree, then obviously the other angle would be 30 now, right? Because I need to find the angle between vectors and x-axis. Okay, that's why. Try to write force equation now. Yashina, you cannot find, okay. You cannot find the answer because there are more than one variable. Okay, you just have to resolve the vectors and write down the equations in x-axis and y-axis, as simple as that, right? So see, right? When you talk about this, mg it is y-axis, t1 is in y-axis. Now t2, you can resolve t2. So t2 can be written as, just write down all the forces, right? So I can say that this t2 can be resolved into, okay, t2 can be resolved into components, yes or no, right? So it can be resolved as, this is t2y and this is t2x. Right, everyone? Tell me. Yes? Yes or no? Yes or no? Okay, that is the sound of my chair. So, after this, you have to balance the forces along axis, along y-axis. First of all, along y-axis. Now tell me, what are the forces along y-axis? So mg in downward direction plus t2y in downward direction, right? Minus t1 in upward direction is equal to m into y, right? Now, if object is not moving in y-axis, so this will be 0. Okay, if it is not moving in y-axis, then this will be 0. But I haven't told anything that is this moving or not. Okay, so this is the force equation along y-axis. Yes or no? Just use your basic concept. Net sum of all the forces is equal to mass into acceleration. Prahlad, right? I have taken the direction negative, right? As C, I have direction. I have taken the direction as negative in upward direction, because when you talk about motion, it will move because of mg now. It will not move because of tension. Have you ever like saw a stone getting pulled up, right, when it is attached to a string? No, right? So tension will always stop the motion in downward direction, but it will never be more than mg unless until there is any other force. Okay, right? Okay, ay is acceleration in y-axis now, right? This is y-axis, so obviously the acceleration would be in y-axis. Yeah, it will act like a friction. Okay, now friction is also complex. It's not as simple because friction can make object move also. Okay, so we'll discuss those cases. Now, which axis we are taking here? Tell me, which axis we are taking here? This force equation is along which axis? Tell me, this force equation is along which axis? Y-axis. So if it is y-axis, then the acceleration should be in which axis? Y-axis only now, right everyone? Got it? This is your basic concept that you should remember. Okay, right? Okay. See, direction of T1 is opposite to T2 and mg now, right? Okay, got it. That's why minus T1. You could have written T1 minus mg minus T2y. It would be same. It doesn't matter because the direction of ay will be in opposite direction. Here, I've considered the direction of ay in downward direction, right? I've already considered. That's why I have taken mg plus T2y minus T1. If you have considered the direction of ay in upward direction, you would have written T1 minus mg minus T2y. What you didn't get, Shakib? Tell me, how many forces do we have in y-axis? Tell me. Just think about this. How many forces do we have along y-axis? Tell me, Shakib. We have 3 forces. 2 forces in one direction and 1 force in opposite direction. Yes or no? 2 forces in one direction and 1 force in opposite direction. So obviously the force which are in same direction will be added and the force which is the opposite direction will be subtracted. Okay, so you can either write mg plus T2y minus T1 is equal to may or T1 minus mg minus T2y is equal to may. Doesn't matter. Okay, the direction of ay will change. Got it? The direction of ay will change now. Right, everyone? Okay, Shakib, you got this now? Tell me, you got this now? This is in y-axis only, right? So I have written 2ty now, right? This 2ty is what? mg plus 2ty is y component, which is t2 sine 30 degree. t2 sine 30 degree. I have written t2y, okay, minus t1 is equal to may. You cannot solve this because there are lots of variables. Okay, my aim is just to know how to write the equation. Now along x-axis, so along x-axis we have only one force, which is T2x. So T2x is equal to max. Yes or no? Tell me. Yes or no? Which is T2 cos 30 degree is equal to max. Got it, everyone? You just have to write the equation. Got this? Tell me. Or if you got this? Okay. Okay, very good. So let's see. So this is case 1, case of strain. So we'll use resolution vectors a lot. That's why I told you it is one of the most important. Yashila, T1 is not in x-axis now. See, T1 is just in y-axis, right? So we don't have any component of T1 in x-axis. Okay. Now, case 2. Case 2. When object is kept on any surface, right? Now this is kept on the surface. Suppose this is kept on table. Okay, this is kept on table. The mass is m. Now what do you think? What are the forces acting on this object? Tell me. What are the these forces acting on this object? Okay, Navya, I'll explain. Just answer this for now. Tell me. Right? How many forces do we have here? 2, right? Yes, very good. One is down direction mg. Now since it is not falling because of this table, now there should be some forces in upward direction. Yes or no? Right? Because of this table? Yes? Right, everyone? Now this is called as normal force. Okay? This is called as normal force. So I can say that force by the surface. Force by the surface when any object is kept on the surface or in contact with the surface or in contact with the surface. With the surface, okay, is called as normal force. Normal force. Okay, normal force. And this is first definition. Second point, it is always perpendicular to the surface. It is always perpendicular to the surface. To the surface. Okay. So in this case, since surface is horizontal, normal is in upward direction. Got it, everyone? Tell me, got this? Right? But consider this case. Suppose we have a wedge. This is your wedge. This is a wedge. An object is kept like this. Now tell me, how many forces do we have here? Ignore friction. Ignore friction. How many forces do we have here? 2 only. Yes, very good. One down direction is mg. Now second is normal. Yes. What would be the direction of normal? Tell me. What would be the direction of normal? Will it be this or will it be this? N1, N2. It would be what? N1 or N2? N1, na? See second point. It will always be perpendicular to the surface. So surface is this, right? Surface is like this. So perpendicular is N2 only, na? Right? So this mistake you should not do, right? So that's the thing. Normal is not always in upper direction. It is just perpendicular to the surface. Okay, means just imagine if we have, wait, okay, so if we had any object like this, like this, right? So there will be force in down direction, which is mg, and there will be force in this direction, which is your normal. Got it? Got it, everyone? Right? Normal is a force which is perpendicular to the surface, right? It is always perpendicular to the surface. It is not in upward direction. It may be in any direction depending on the surface. Okay. In this case, surface is like this slant, so it is perpendicular. In this case, surface is vertical, so normal is in horizontal direction. Got it? Yes, Abhay, what doubt you have?
Sir,
Yes?
so if the second object would be touching the ground, then the normal would be towards upwards, sir.
Yes, yes. It's not touching the ground now. It is
Okay, sir.
here, right? Now just I'll ask you, all of you, one problem, right? Now, how many of you have seen this death wall where the motorcyclist just drive along the wall? You have solved this, right? This was a question, okay, in your normal textbook and all, right? The death wall, okay, where the driver right perpendicularly on the wall. Yes or no? Right? So this is that case only. Okay. We will discuss that case again numerically. So I guess most of you have a class at 5 o'clock, I guess. Okay. So I guess all of you understood these two cases? Yes or no? All of you understood these two cases? Everyone? Because what you didn't get? Tell me what you didn't get. Now where you got everything? Yes. Right? Very good, Janvi. There are 3 students who left the class earlier. Not 3, there are many students I do. Okay, right? So what we have studied till now, we studied how force is resolved, how to find acceleration when we have multiple forces, which is called as superposition of forces. Okay, then we studied how to draw free body diagram. Okay, see, when you have to draw free body diagram, just think about this. What is a free body diagram? It is representation of all the forces acting on an object. Yes or no? Right? Okay? Yes, yes, Navya. I'll share the recording. So I can say that first approach should be identifying all the forces. That's why I'm teaching you about all the different forces. Tension force, normal force, right? So you should know what are the forces acting on an object. Okay. Yes, yes. Okay, that is your gravitational force, centripetal, centrifugal, right? Any object which have, which is basically uh, in contact, but be it either they're touching or they're not touching, right? If they have force, right, there will be free body diagram. Okay, free body diagram is nothing, just the representation of all the forces. Okay, got it, everyone? Okay. Okay, just message all the doubts in the foundation group only, Yashila. Okay, I'll explain. Right? Message all the doubts in foundation group. Okay? Right? Okay. Okay. Thank you everyone. You have a class, I guess, after 5 minutes. So we will continue this on Sunday. Okay? No, no. If you have any doubt, if any one of you have any doubt in the foundation book that I've sent, okay, please just take the snapshot and send it in the WhatsApp group. Okay, the foundation group. Okay, okay, okay. Bye everyone. Thank you. I hope you understood today's class. Saturday. Saturday I have already 2 classes, Jayati. Okay, and I'm having an appointment with doctor also on Saturday. That's why I can't take on Saturday. Okay. Okay. Bye everyone. Thank you everyone. Yashash will discuss everything in next class now. Okay. Bye everyone. We will see Shakib depending on the content. Okay. Bye everyone.